Hi, everyone. We're working on chapter 3 here in our statistics book. This chapter is titled Correlation and Prediction. Again, as I said, maybe in a different email, I'm only going through about uh, half or maybe three-quarters of this chapter as the second half of it that is on regression. We are not covering because that's a more in-depth, complex um, a piece of information that, well, it's not necessary for educational statistics, in my opinion. So this is the last part, probably the last third of the quiz for chapters 1, 2, and 3. With that said, let's take a look here and jump right in. Um, correlations, okay? So correlations are a way to show a relationship between two different variables. Okay, and so that's kind of what this section here of the chapter takes a look at. Okay? Some different ways to represent that include scatter diagrams. Okay, so a scatter diagram shows the pattern of relationships between two equal interval variables at a glance. Remember from last chapter, we touched base briefly on equal interval variables and what those look like. Okay, so here you can see an example of a scatter diagram. So we have uh, marital satisfaction and exciting activities with partners. It's doing things. So each of these dots represents a spot or a place, obviously along um, or response to this, whether it was a questionnaire or a survey or whatever it is. But 113 people, there's 113 dots within here somewhere on this scattered diagram. So you can see what the correlation between those components is there. How do you make one of these? What do these look like? What do they when they're put together? So obviously, if we look at these steps here, an axis, okay, draw the axis, decide which variable goes on which axis, okay, right here. Right? What is the range of values you're going to use for each variable, and then put them on the axis. So numbers should go from low to high on each axis, starting from where they meet. Okay, so obviously you can see here zeros here, 10, 20, 30, 60, 1 through 5 there. So low to high, low to high. Make a dot for each pair of scores. Okay? Find the place on the horizontal axis, and then move to the height for the vertical axis, mark it as a clear dot. So that kind of makes sense for the horizontal and vertical axes that you place those dots right on those spots there. So it's a pretty simple three-step process to making a scatter diagram. It's a very simple way that you can represent some information. Now, there's different patterns of correlation that we want to be aware of. So we have a linear, curvilinear, and no correlation. And we'll take a look at these here in a minute. But linear correlation shows that there's a relationship between the two variables that shows up on a scatter plot or scatter diagram as dots approximating a straight line. Okay? So if we go to figure 3.5, which is this one here, you can see it's somewhat close. It's not exactly on that, but you can see that there's several here that are on a straight line and these ones that are somewhat close. Okay, so again, as we said, that's a proximate straight line. Now, curvilinear correlation shows that the association between two variables other than this straight line or linear correlation. And it shows a systematic pattern that is not in a straight line. Okay? So here you can see that this curves a little bit more, right? So curvilinear relationship. Right? So it might be straight for a little bit, but then it goes off in a different direction. This you would not necessarily have in regards to a curvilinear, even though they're not all in a straight line, they're somewhat along that axis piece there. Okay. And then there could be no correlation, where there is no specific pattern of correlation in these examples. So here you can see if they're all over the place, okay, there's no way we can make a connection between any of these pieces of data here. Right? So linear, curvilinear, no correlation. Okay. Now we can also have a positive and a negative linear correlation. Right? So positive correlation. high scores with high, low scores with low, medium with medium. Okay? So when these are graphed, the line goes up and to the right. Okay? Negative correlation, high scores go with low scores, and when graphed, the line goes downward to the right. Okay? Example here, this would be a negative correlation because we start here on this end and we're trending downwards with that. Okay? Um, so the example that it gives there in regards to that type of correlation. Right? So the opposite, of course, of that positive correlation would be if this was flipped, right? If it would go up in this direction. Okay? What is the strength of a correlation tells us? Well, clear patterns of some particular relationship between the two variables. If you have, whether it's a positive or a negative correlation, there is a strength in between that. How close the dots on a scattered diagram fall into a simple straight line, right? So the positive correlation then is how much highs go with the highs, where the negative is with the highs, and they go with the lows. Okay? So you can have positive and negative correlation, and they can both be strong. There are some examples here, right, of these different types of scatter plots or scatter diagrams that we've been looking at. Here you could see potential positive, here potential negative, different scatters where there's no correlation here, for example. The thing to take that we should be aware of is the correlation coefficient. Right? I'm going to talk about something here in a minute called the Pearson correlation. To determine the direction and strength of linear correlation. So a number that gives the exact correlation between two variables. So this can tell you both the direction and strength, and it also uses the z-scores that we touched base on last chapter to compare scores on different variables. So z-scores allow you to calculate a cross product that tells you the direction of the correlation. Remember, z-scores will tell us a standard deviation, right? And so where we may not be able to look at two different variables from a raw score, a z-score will help us to look at those different variables. Right? So a cross product is a result of multiplying a score on one variable by a score on the other. Right? So here it talks about high and low, high z-scores and low z-scores and what those could potentially look like. So a high z-score multiplied by a high z-score is a positive cross product. Low multiplied by low is also positive, but if you have a high multiplied by a low or a low with a high, you're going to have a negative cross product. So if you take a look at that, the same types of z-scores multiplied together are positive, where the opposites, the highs and lows multiplied together, are going to give you a negative cross product. Okay. So if highs always go with highs and lows always go with lows, the cross products will always come out positive. Right? Again, if lows go with highs, it'll come out negative. So if highs sometimes go with low highs and lows, if highs sometimes go with highs and lows, sometimes go with highs. I'm sorry, that doesn't make any sense to me, and I have to look into that in terms of what that means. Okay? But basically, you're going to have like a zero, or you're not going to have any positive or negative component of the z-score there. Right? But in general, highs and lows together is going to give you a positive. But if lows and highs are mixed together, it's probably going to be. This is the Pearson correlation coefficient I was talking about. Okay? Within the book and within the quiz there, I do have a question on that. But if you provide it, show you an example here, I think. Maybe not. So the sign of R tells the general trend of a relationship between two variables. So if you think of the letter R as meaning a relationship between them. Okay? So obviously, plus means it's a positive relationship, and negative sign means it's a negative relationship. Values of this Pearson correlation coefficient can be from 0 to 1. Okay? and the correlation. So one is the highest value of correlate. One is the highest value of correlation you can have, right? And a correlation of 1 or -1 mean that variables are perfectly correlated. Okay? There's a 0, there's no correlation. Right? So you can have a decimal, or you can have, obviously at that. So -0.99 is a stronger correlation than 0.75. Okay? Remember, just because it's a negative correlation doesn't mean it's a bad correlation. It means that it's stronger, right? So the closer you are to 1, the stronger, whether it's -1 or +1, the stronger that relationship is between those two variables. Okay. And then the last one I'm going to look at is I do have some examples or a question on there in regards to the steps in how you can figure a correlation coefficient. Okay, so take a look at that. Again, not that you have to remember how to do that, but just take a look at these steps in regards to what it looks like to figure a correlation coefficient to see what those, if you have a 0 or a -1 or a +1, whatever that might look like. Okay, so there's not a whole lot of stuff, again, like I said, from chapter 3 that I'm having you take a look at, but just a few things in regards to correlation and a few things on prediction and what those could look at. The biggest one, I think, that is interesting to me is the scatter diagrams, right, where you can see connections or correlations if there are some, or if there is not any correlation between variables at all. Okay, so chapter 3, use that. Chapters 1, 2, and 3 quiz all connected together here. I think there's about 50 questions, so there's a fair amount, but it's over 3 chapters, right? So take a look at that. Use your book, use the PowerPoints if you can on that to help determine the answers to these questions. Okay, take care. We'll see you next week.